Good evening, everyone. So, in this live session, we'll be discussing variables and expression. The topics which we'll be covering are right in front of you. And though I have opened class 11 syllabus, this is something which is common from class 9 to class 12. So, let's begin. So, we'll be first talking about what is a variable. So, a variable is, you can say, a name given to a location in memory. And just like in maths, you use symbols to represent some storage. The same thing happens over here as well. So like, say for example, I say int a is equal to 2. So what it means is that somewhere in the memory, computer is going to allocate 4 bytes for your storage, and then we are storing the number 2 in that location. So this is the meaning of a variable. And this equal to is an operator. Specifically, it's an assignment operator. And here the sense is that the value 2 is being assigned to the variable a. Now, before we proceed, please understand there are certain rules for naming a variable. And whatever these rules are, they are basically rules for identifiers, meaning that they'll apply to any name which we are giving to anything in a program. Like for example, the class name is an identifier. This argument is also an identifier. The variable a is also an identifier. So let us see what these rules are. So the first one is that name can contain letters, digits, underscores, and dollar signs. And the important thing is that even though it can contain letters, digits, underscores, and dollar sign, it must begin with a letter or an underscore or a dollar. The point is it cannot begin with a number. So like for example, I can say that there is a variable a2, that is okay, but I cannot say there is a variable 2a, that is not allowed. So a variable cannot begin with a number. Now, names are case sensitive. That is, whether I say a or I say a is equal to 2, these two things are different and they can coexist. It's not necessary that both of them should be same. And there is one more rule, that you cannot have any reserved words used. Like say for example, I cannot say int final is equal to 2 because final is a reserved word. And please note, I'm not saying keyword, I'm saying reserved words. There's a slight difference between the two. And the difference is that all reserved words may or may not be keywords, but all keywords are reserved words. Why I'm emphasizing this is, like for example, there are two reserved words which are not keywords. They are const and goto. So even though goto is not used for anything, I cannot say that okay, goto is equal to 2 because goto is a reserved word. It doesn't mean anything, so it's not a keyword in Java, but it is reserved. The same goes for const also. Const is reserved, but it's not a keyword. And obviously keywords cannot be used because they have some other meaning for the Java compiler. So I cannot say that okay, int for is equal to 2 because for is a keyword. That's one thing. There's another thing is that though technically, like now this one depends on whether or not you are using Java version 9 or later. So before Java 9, underscore was a valid variable name, but after Java 9, that is not a valid name anymore. This is also actually a keyword now. So underscore is a keyword from source level 9 onwards, cannot be used as identifier. And just for your information, this is used in lambda expressions to denote unused arguments. Anyway, but that is simply out of the syllabus, so we won't go into the details of this. But please understand that underscore is no longer allowed as a variable name. It was allowed at one point of time, but not anymore. That's one thing. So the program is not going to compile unless and until I remove this last line. So let me remove this last line. I'll remove the other lines also because they have served their purpose. Okay. So int a is equal to 2 means that there is a storage location a, which we are calling as variable, the value of which is 2. Another point to note over here is that if I don't initialize it at the beginning and then let's say I try to use it, let's say I want to print the variable a. So if I go over here and I try to print the variable, please note this doesn't contain any value. So the error is the local variable a might not have been initialized. So you cannot use a variable in Java unless it is initialized. And right now I'm talking about the local variable. If you have an instance variable, like say for example, if I go over here and here I say that okay, int a, or let's change the name, int b, then this variable, that is the instance variable, will be initialized to 0, but local variables are not initialized to 0 on their own. So if you have to use it, we have to give it a value. So like for example, if I say a is equal to 2 again, now the program is going to compile and run. Let me run it for you once. So here we are, the program is compiling and we are getting the answer 2. That's one thing. The other thing is that we can define constants also. And like I told you earlier, there is a reserved word const, but it's not a keyword. So for declaring something as a constant, we have to declare that that given variable is a final variable. So once I say that the variable is final, what it means is that its value cannot be changed. So if I say final a is equal to 5, this line, that is line number 4, is going to give you an error which says the final local variable a cannot be assigned, it must be blank. The reason is that since it is final, it has to be initialized immediately, and once it is initialized, it cannot be changed by definition. So that's the meaning of a final keyword in this context. Please understand, final means other things also. Like for example, if I declare a class as final, that is I write final over here, then the class cannot be inherited. Similarly, if I make a function final, that function cannot be overridden in case of inheritance. So final is used in 3 senses. A variable can be made final, a class can be made final, and a method can be made final. Right now we are only concerned with the variable. The other finals will come at an appropriate time at a later stage in our course. Okay, so this is one thing. So once I say that a variable is final, I cannot change its value. So let me remove this out of the way. So this is another concept which I wanted to discuss. Now that's one thing. Now obviously if we are simply assigning values into a variable, it's not very useful. So what makes it useful is that there are operators which allows us to perform different types of operations. Now those operators can be divided into various categories, like there are arithmetic operators, there are assignment operators, there are comparison operators, there are logical operators, and there are bitwise operators, out of which the last one, that is bitwise operators, are not in the syllabus, but the other operators are there in the syllabus, and we are going to discuss them one by one. So let's begin with the first one was arithmetic operator. So what I'll do over here is I'll give a comment to separate. So the first thing which I'm going to discuss is arithmetic operators, and these are usually the simplest one. Arithmetic operator means that we'll be using plus for addition, we'll be using minus for subtraction, we'll be using asterisk for multiplication or product, we'll be using slash for division or quotient, and we'll be using percentage sign for remainder, or we technically call it modulus, and we use plus plus operator for increment, and we'll use minus minus operator for decrement. Okay, let's see them one by one. So what I'm going to do right now is I'll just cut it from here and we'll go over here and let me have a few more variables. So a is equal to 5, let's say b is equal to 2, and we'll store the result in the variable, let's call it result. So the first one is addition. So if I say result is equal to a plus b and I try to print it, I'll get the sum. So I'm just running this program for you. So 5 plus 2 is 7. Similarly, if now I'm not going to run it again and again because this is very trivial, but yes, wherever there will be something worth emphasizing, then I'll actually run it. So plus is for addition, minus is for subtraction, that is 5 minus 2 is 3. Similarly, asterisk is for product. So if I write an asterisk over here, it will find the product of the two numbers. Similarly, slash is for division, and then modulus is for remainder. Now, this we'll discuss a bit. So here I am saying 5 modulus 2. That is, what is the remainder when 5 is divided by 2? So I'll just bring my software for scribbling something. So please understand, I'm talking about 5 modulus 2 right now. That is remainder of 5 divided by 2. That is 2 ones are 2, remainder is 3. Now, if we say 2 modulus 5, then it will be remainder of 2 divided by 5. That is 5 into 0, 0, and the remainder is 2. So in the first case, the answer will be 3. And in the second case, the answer will be 2. Now, this has many uses in programming, which we'll see later. The most common one is it is used to extract the last digit of a number. So notice if I say 25 modulus 10, I get the last digit. Notice 10 into 2 is 25, remainder is 5. The 5 is extracted. Similarly, if I say 1, 2, 3, 4 modulus 100, I can extract last 2 digit of the number. Just to demonstrate, 1, 2, 3, 4 divided by 100. 100 into 12 is 1200, remainder is 34. So this we'll see later when we'll move on to programming, but this is important. Okay, now let me move this window out of the way, or I'll just close it. We'll open it again if required. Okay, so then we have the increment operator. That is, now this comes in two varieties. I can have it in the form of pre-increment, that is plus plus a, for example. I can have it in the form of a plus plus, that is post. So let's see the difference between them. So if I say that the initial value of a is 2, and I say system.out.println plus plus a, here the value will be first increased and then used. That is, computer will be taking the value 2, increase it to 1, and then it will print 3. So if I run the program, see, the last output is 3. The other form is when I place the plus plus at the end. Now what will happen is that first the computer will use the value in this case 2, and then it will increase it to 3. So when you are using the prefix version, first the value is added, then used. When you're using the postfix version, the first it will be changed and then used. Okay. And one more thing, I made a slight mistake over here. 5 modulus 2. Okay, it's not actually a mistake. I was showing over there for 5 and 3, and here it is 5 and 2. Okay, anyway, so that's one thing. Now let's move down further. So here, okay, let's run this first. So a equals 2, we'll first print 2, and then the value of a will be increased. So let's display it once more so that we can see what is happening. So if I say at the end that, okay, a is equal to plus a, and then I run the program, see what happens. computer displays 2 and then the value of a becomes 3. So this is one thing. The same thing will happen in case of decrement, but instead of adding, we are decreasing. So I'm just going to skip it in order to save some time. Okay, that's done. Now, with the basic operators out of the way, no, it's not out of the way yet. There are some more left. So the second type of operators are assignment operators. So I'll just clear this out first because we have already seen them in action. Now, next is our assignment operator. Now, one assignment operator we have already seen, that is equals. There are other variations also, like for example, if I'm saying a is equal to a plus b, the same thing can be written as a plus is equal to b. Similarly, if I'm saying a is equal to a minus b, the same thing can be written as a minus equal to b. So the second form is known as a shorthand notation, in which you are not required to write the variable twice. You just mention it once with this syntax. Now, for most practical purposes, now whatever I'm talking about will hold for all of these: minus equal to, plus equal to, asterisk equal to, slash equal to. The point is that they are not completely interchangeable. Let me elaborate a bit. So what I'm going to do right now is I'm going to say first that, okay, result, no need for result, we'll manage with a and b. So I'm going to remove the variable result from here right now. So notice what is happening now. I'm saying a is equal to a plus b. If I display the answer, that is a, 5 plus 2 is 7. So if I run the program, 5 plus 2 is 7. That's perfectly okay. If I use the shorthand notation, that is, instead of this, I say a plus is equal to b, I am still going to get 7, which is also normal. And this seems to suggest they are exactly identical, but that's not the case. And that case is like, say, for example, if I change the type of the variable, I say that a is equal to, a is integer, and let's say I say that b is long. Now notice what is happening. If I say a is equal to a plus b in this case, we are going to get an error. The reason is this is a mixed expression. Variable a is of type int, variable b is of type long, and the variable a on the left hand side is of type int. So the type on the RHS, that is right hand side, is long, which is bigger than the data type to which it is supposed to be assigned, that is int. So this cannot succeed unless and until I do the typecasting. That is, if I say that, okay, I want to convert the output of a plus b into int, then this can be done. But otherwise, this is going to give an error. However, if I comment out this line and I use the shorthand notation a plus is equal to b, you'll see that the line is compiling. So this is the point which I'm trying to emphasize right now, is that shorthand notation and the regular notation are not exactly identical. In case of a shorthand notation contains a hidden cast. That is, typecasting is done behind the scenes automatically for you, whereas in the direct notation, you have to do the typecasting yourself. And this applies to all the shorthand notations, that is plus equal to, minus equal to, multiply, asterisk equal to, slash equal to, modulus equal to, etc. So this is something which is not usually mentioned in the school level books also. But since now MCQs come, they can write a question, they can frame a question around this. So it's a nice to know thing. So this is the shorthand notation. Now, once this is done, then there are comparison operators or relational operators. So I'll again remove all this. We'll have two variables once more. Let's say a is equal to 5, b is equal to 3. And now we'll talk about the relational operator. So relational operator means whether or not something is equal to something. Like for example, if I say a equal to b, in this case, we'll be getting false because 3 is not equal to 5. So we are getting a false. Similarly, we can have more than. So I can say a is more than b. So is 5 more than 3? Yes. So this time we are going to get a true. Then there is something known as a is less than equal to b. So if I make both of them 5, a is less than equal to b is true because they are equal. So now we are getting a true. So the operators are, or rather the relational operators are equal, equals for equal to, not equal to is denoted by an exclamation like this. So a is not equal to b, 5 is not equal to 5, that is false. So if I run the program again, I am going to get a false. If I change the value of one of the variables and I run it again, it will say true. So there is an equal to, there is a not equal to, more than, less than, more than equal to, and less than equal to. So we have talked about arithmetic operators, we have talked about assignment operators, we have talked about relational operators, and the only one left, actually there are two left, but one is not in the syllabus. So the only one left now is Java logical operators, and that is something which is used to combine more than one condition. So like say for example, I can say a is less than 5 or b is more than 2. So what it means is that computer will evaluate a is less than 5. It will also evaluate b is more than 2. And the idea is or. Or means if any of the condition is true, the resultant will be true. And there is one more thing which happens behind the scenes which is not usually visible, that we'll see just in a moment after we have discussed and also. So here the idea is that we are performing an or operation. Or operation means result is true if any of the operands is true. The other one is and. And means, like for example, I say over here, a is more than 1 and b is more than 2. So now here, when both of them are true, only then the final result will be true, otherwise it will be false. So and means result is true only when both of the operands are true. Now please understand, I am demonstrating this for the case of 2, but there might be 3, 4, 5, whatever. There is no limit to it, that how many and or you can place. The last of the logical operator is not, which is used for inverting something. Like say for example, I say int age is equal to 18, and then I say boolean can vote is equal to age more than or equal to 18. So what is happening is this boolean variable is storing the result of this operation. So in this case, 16 is more than equal to 18. No. So if I say system.out.println can vote over here, it's going to say false. See the last output? The output is false. However, if I place a not over here, the value will be inverted. That is, this false will now become true. And obviously I'm doing it at the time of printing. If you want, you can do it over here also. So I can say not like this. So we have covered and, or, and, not. So these are the logical operators which are available to you. One more thing which I was saying that I would like to emphasize, but I forgot. And that thing is that please understand, computer over here it tries to optimize things. When I say optimize, what I'm trying to say is that if the first condition is true in case of an OR, it's not going to evaluate the other conditions in order to save time. In the same way, if any of the condition in an AND is false, it's not going to evaluate the remaining one. Let's say I want to demonstrate that this is happening. So what we can do is, very quickly I'll demonstrate. So what I'll do is, I'll create two methods which return. We'll be going into the details of the methods later on, but right now, since this is directed towards 10th, 11th and 12th students, so you already know what is the method. So I'll say public static boolean. Let's say there's a method f1, and within f1 I'm just doing very simple thing. I'm saying inside f1, and then I say return true. Then I'm going to make a copy of this function and I'm going to call it f2, and here also I'll say inside f2. Now notice what I'm doing. So inside the main I'm saying system.out.println and I'm saying f1, and first we'll check it with OR. So f1 or f2. So what is specifically happening in this case is that computer will evaluate f1, it will see that we are returning true, then it will not evaluate f2 because the first one is returning true. So it will only display inside f1. It will not go inside the function f2, even though over here it appears that in order to compute the result you need to evaluate everything, but that's not going to happen. See, if I run it, see what happens. It goes inside f1, but it doesn't go inside f2 because computer knows that, okay, if one of them is true, the result will be true. Why waste time in evaluating the other methods? Similarly, if I make it false, now it is going to evaluate the second one as well. So if I run it once more, see, it goes inside f1, then it goes inside f2, and true and true both, false and true is true. So the final output is true. Now the reverse happens in case of an AND. So if I say AND over here, and the first one is returning false, it's not going to evaluate the second one. Let me run it again. See, it's only going inside f1. That function f1 is returning false, and hence computer never goes into the second method, that is f2. However, if I make this equal to true, then the control is going to go inside both the methods. So this is an optimization technique which is performed behind the scenes. So be careful if a question is asked, or rather an MCQ is asked, because the normal tendency is that, okay, what will be the output? It will go inside both of them, but that's not the case. It depends on what the method is returning. That will decide whether it's going to enter into the second one or not. So this is something which is not mentioned in the books usually. But anyway, even if it's not mentioned in the book, now you know it. And then there is something known as precedence and associativity. Let's talk about them. So associativity means, okay, let's talk about precedence first. What does precedence mean? So what I'm going to do over here is, I'm going to create a very simple example to explain precedence. So let's say I have an expression over here. I'm saying 2 plus 3 into 4. So precedence means that if there are more than one operators, in which order it will be evaluated. So this is the computer counterpart of what you do in maths called BODMAS. So first brackets are brackets, then division, multiplication, addition, etc. So the computer counterpart of that is known as operator precedence. So like in this case, even though 2 plus 3 is coming first, computer will first perform the multiplication, because in the precedence, multiplication comes before addition. So 3 into 4, 12, 12 plus 2, 16. So this is something known as precedence of operators. Oh, sorry, 3 4s are 12, 12 plus 2, 14, not 16. So this is one thing. Now, there is a detailed, table given in the books which lists everything. Let me see if I can fetch it quickly. Okay, yes, there it is. So let's see, like, this is the operator precedence. First, preference is given to the postfix. Then you get unary, that is this one. Then multiplicative. Multiplicative means either asterisk, slash, or modulus. Then the additive, that is plus or minus. Shift is a bitwise thing, it's not in the syllabus. Then relational operators are performed. Then equality again. Then bitwise and or and exclusive or inclusive or, again this is also not in the syllabus. Then logical and, logical or ternary, and at the end the assignment is performed. Now a question might be coming to your mind that what if both multiplication and slash are coming, and this is where the associativity comes into picture. So if you have an expression in which there are two things which are having the same precedence as per this table, like say for example, let me go over here, and let's say if I say a this plus minus this, so 2 plus 3 minus 4. Now what will happen in this case? So in this case, since the precedence of plus and minus are equal, computer will simply move from left to right. So this is something which is also important to know. So some operators, most of the operators have left to right precedence, and some of them has right to left. Like say for example, if I do assignment, like say for if I say int a comma b comma c, and then I say that okay, c is equal to 2, and if I say a is equal to b is equal to, let's say, 5. So first, now here, first 5 will be assigned to b, and then 5 will be assigned to a. So this is moving from right to left. You'll find that there in the book, usually in the books, they have either there's a separate table for associativity, or there is a precedence table in which associativity is mentioned at the end. So that is something known as associativity of the operators. And I believe that we have covered almost everything which was mentioned in the syllabus. Let me check it once more. LHS, RHS also we have talked about. Anything else on this side? Okay, one thing more we need to emphasize is that unlike in maths, here the ordering is important. That is, if I say int a comma b comma c, and I say that okay, a is equal to 2, b is equal to 3, and then I say c is equal to a plus b. The idea over here is that we are not trying to say that the LHS is equal to RHS. We are trying to say that whatever is in the RHS is to be transferred to the variable on the left hand side. That means you cannot say that a plus b is equal to c like we sometimes do in maths. Here this will give an error because this is a value, this is an expression, and you cannot store a value into the expression. That is simply not possible. So this is an incorrect example, so I am commenting it out. So when you say LHS is equal to RHS, it means that we are trying to do assignment. So with this, we come to the end of this topic of the syllabus. So if you have any doubts, you may ask your question now. And I have a comma by mistake over here. It should be semicolon. So it seems that no one has any issues with this. So I'll end this stream now, and in the next class, we'll be talking about the next topic, that is point number 7, which is statements and scope. And it is from this point onwards that we'll be having programming sessions as well. That is, we'll be writing a more full-fledged programs rather than this toyish example. And one more thing which I would like to add, that is not in the syllabus, so you may want to skip it, but still it's something nice to know. And that is, in recent version of Java, it is allowed to have, in case of local variables only, I can say var, and there is no need for me to tell what is the type of the variable if I'm assigning it immediately. So for example, if I say int a is equal to 2, computer will assume that it's an integer. So if I run this program, I'm going to get 2. No need to tell the type. So if I say 2.0, computer will assume it's a double. Similarly, if I say this is equal to test, computer will assume it's a string. And in the same fashion, if I say that var a is equal to true, it will assume it's a boolean. So this is something nice to know. If you are having a local variable, there it's not necessary for you to explicitly state the type. If you are making an assignment, computer can make out from the assignment that, okay, what's the type of the variable. So with this, we come to the end of this session. Thank you for joining in.